Forget the giants, the true Mesozoic story is microscopic. But hidden within this dust lies an entire vanished world. These are microfossils, the planet's smallest, oldest historians. They existed before the first great reptiles walked. And now that we understand their age, let's explore their structure. Coccolithophores built exquisite plates of calcium carbonate armor. But these tiny architects were foundational to ancient marine food webs. Consider the Foraminifera, single-celled organisms with complex shells. Their chambers acted like tiny, sophisticated life support systems. And the currents carried these planktonic travelers across ancient seas. But not all Mesozoic micro-life was marine. Terrestrial realms had their own secrets. In ancient riverbeds, tiny spores and pollen tell a different story. Pollen grains offer definitive proof of the dominant Mesozoic flora. But we track floral evolution through layers of deposited, microscopic debris. And now that we understand X, let's explore Y, the significance of these fossils. They are the indispensable correlation tools for geologists worldwide. Because microfossils are small, they are abundant and widely distributed. This abundance allows us to date rock layers with great certainty. A certain species appeared, flourished, and vanished rapidly in geological time. This extinction signature is preserved, marking a definitive boundary marker. The chemical signatures locked within these shells reveal ancient ocean chemistry. Oxygen levels, temperature, salinity, all recorded in crystalline precision. But this level of detail helps us reconstruct the Mesozoic climate puzzle. These tiny organisms underpin the very ecosystems the dinosaurs inhabited. Consider the dinoflagellates, often responsible for vibrant, complex blooms. Their modern descendants still populate our oceans today, nearly unchanged. They are the persistent threads linking deep time to the present moment. Our sedimentation rates dictate how well these fragile records are preserved. The deep sea cores provide the quietest, most undisturbed archives available. Extracting these cores requires immense engineering prowess and precision. Each meter of core represents millions of years of biological history. But notice the shift from thick siliceous oozes to calcareous layers. And now that we understand X, let's explore Y's of the role in mass extinction. The KPG boundary is clearly marked by the sudden disappearance of many taxa. The impact event caused rapid ecological collapse on a microscopic scale. The recovery was slow, initially dominated by resilient, opportunistic survivors. These survivors laid the groundwork for the Cenozoic radiation of new forms. But terrestrial records are harder. but fungal spores offer critical clues here. A spike in fungal spores often signals widespread ecosystem distress or decay. And these tiny indicators reflect the health of the entire biomass above. But don't overlook the diatoms. Siliceous algae were also vital players. Intricate pores managed nutrient uptake and shell formation efficiently. Over eons, diatom shells accumulate to form thick layers of chert rock. Tectonic activity and erosion constantly challenge our ability to find them. But paleontologists use specialized preparation techniques to unlock these fossils. The preparation must be precise. Even minor contamination yields false data. We are looking for subtle surface imperfections that prove authenticity. Modern imaging allows us to see inside the structures without destroying them. A computed tomography reveals internal chambers obscured from surface view. But the collective impact of these small lives define the world above. Their calcium carbonate skeletons eventually became the limestone bedrock. The very mountains we see owe their existence to these tiny sea dwellers. If you look closely, you can see the ghosts of their shells everywhere. Even river systems, feeding the seas, carried their microscopic signatures. But these depositional environments trap records of both land and sea life. Finding an anomaly, a species outside its expected time range, rewrites chapters. Each new find forces us to refine our understanding of adaptation. The giants faded, but the microscopic world persisted, adapting and continuing. The greatest narratives of Earth history are often written in the smallest script. Respect the microfossil. It holds the key to the macro past.